In this video, I am going to share some important points about a moving coil galvanometer, like what is a galvanometer used for, various parts of galvanometer, principle of working of galvanometer, what is the theory of working of galvanometer, what is the meaning of sensitivity of a galvanometer. A galvanometer is an electrical instrument that is used for detection and measurement of electric currents of small magnitude. A galvanometer consists of a coil having large number of turns of insulated copper wire. This coil is wound over a core made of some non-magnetic material. The coil is suspended from terminal T1 by means of a phosphor bronze wire. The other end of coil wire is connected to second terminal T2 through a highly elastic air spring made of phosphor bronze. A uniform magnetic field is applied on the coil with the help of a concave-shaped cylindrical north and south poles of a horseshoe magnet. The concave-shaped poles of magnet provide a radial magnetic field such that plane of the coil remains always parallel to direction of external magnetic field. The principle of working of a galvanometer is that when electric current is passed through a coil held in some external magnetic field, a torque acts on the coil that deflects the coil from its normal position. In this figure, theta represents the angle through which plane of the coil rotates due to this deflecting torque. Magnitude of the deflecting torque due to external magnetic field is given as N multiplied with I multiplied with B and A, where N represents number of turns in the coil, I represents magnitude of current passed through the coil with the help of terminals T1 and T2. B represents magnitude of magnetic field acting on the coil due to poles of horseshoe magnet, and this small letter A represents area of cross section of plane of the coil. When plane of the coil rotates through angle theta, the suspension wire also gets twisted through the same angle theta. A restoring torque comes into play in the suspension wire, due to which the coil tends to restore its original position. If K represents restoring torque per unit twist of material of the suspension wire, then restoring torque acting on the coil can be expressed as tau restoring is equal to K into theta, where theta is angle of twist that takes place in the suspension wire. The coil comes into equilibrium when both the types of torques become equal in magnitude and opposite in direction. Comparing restoring torque with the deflecting torque, we can write K theta is equal to NIBA. It gives the value of theta as equal to NBAI divided by K. On right hand side of this result, N, B, A and K are constant quantities for a particular galvanometer. So we can write theta proportional to I. That is, angle of deflection in coil is directly proportional to magnitude of electric current passed through the coil. A galvanometer is said to be very sensitive if it shows large angle of deflection theta when small current is passed through it. Deflection produced in the coil of galvanometer per unit current passed through it, that is theta upon I, is called current sensitivity of the galvanometer. From previous result for angle of deflection, we can write current sensitivity theta upon I is equal to NBA divided by K. This result shows that current sensitivity can be increased by using strong magnet and by suitable selection of suspension wire having value of K as small as possible. N and A cannot be increased beyond a limit so that galvanometer does not become very bulky. Thanks for watching the video.